Okay, now let us go to question number 9, which is page number 5. Question number 9, we have an incline and two objects. Object number 1, which is a box, and object number 2, which is a ball. The mass of the first box is 20 kilograms. The angle is 40 degrees for our level, and the mass for the ball is 14 kilograms. We have a tension in the string here. Okay, I think we have a question the same like this one, but without any angles. Okay, let us look at the free body diagram. The forces acting on the box. We have the weight, which is M1 multiplied by G. It is downward. The movement is with the level, and this level has a slope 40 degrees in 40 degrees. Okay, so we need to find the components of this force, which is the weight, with respect to our level. So we need to draw XY plane, but our XY plane is rotated with this surface, so this will be rotated with this surface. So we have XY plane and rotated 40 degrees to go with our surface of motion. Okay, in this case we have this degree is the same like this one. This is our secondary XY plane. We have a component on negative Y axis for the weight, which is M1G cosine theta, because it is next to the angle next to this axis. The opposite axis, or this one, the perpendicular axis, which is M1G sine theta. The acting force in this direction comes with sine theta. The perpendicular force in this direction with cosine theta. We have a normal force. It is the same like this one. The normal force is equal to M1G cosine theta, but opposite with it and perpendicular to the surface. Always the normal force is perpendicular to the surface. We have the tension in the string. Also, for the second body, we have the weight, M2 multiplied by G, and the tension. Like the previous question, we need to suppose positive and negative directions. So we can suppose this direction is positive and this direction negative. So any force with this direction is positive. So this force will be positive. The tension with the opposite direction, it will be negative. This will be positive. This will be in negative direction. When I write the equations for the ball, I have look here before this line. Next, because of the Newton's second law, the total external forces are equal to mass multiplied by its acceleration. I have here mass number 2, not 1. Okay, what are the external forces acting on this mass on the ball? It is the weight with positive direction and the tension with negative direction. So the weight minus the tension is equal to M phi A in A multiplied in A. Okay, phi means N multiplied by A. Okay, for the box, I don't care about the perpendicular forces because it will not move in this direction. it will move parallel to the surface of motion. And that what is important to me. I have the Newton's second law for the first body, m1 multiplied by its acceleration. F external is equal to m multiplied by the acceleration. Okay, what we have now, external forces on the box. We have its mass, its weight, friction in this direction with the weight mg. With this direction, the component parallel to the surface with sign. The cosine is here. It is in negative direction because in this direction we suppose it negative. So minus m1 g sine theta minus the tension with the positive direction. So the tension is positive here is equal to m1 multiplied by a. Now I name this equation number 1 and this equation number 2. As we did before, we need to add equation 1 to equation 2 to find a. If we add them together, this equation 1 m2 minus t, the left hand side, plus the left hand side from the second equation, which is minus m1g sine theta, this one, plus t is equal to right hand side in first equation, which is m2a and m1a, add them together. Okay, I have here negative t, positive t, I can cancel them together, and now I have just one unknown value, which is the acceleration. m2 is known, 14, g is known, g is positive because it is with my direction. This is g in this direction. Okay, m1 with negative sign, m1 is 20, g is known, sine theta is sine 40, is equal to a, which is common between them, I can get it out, and m2 is 14, m1 is 20. So the acceleration I can divide it over to this value, which is 34, and this side, all of it is equal to 11.2. Divided it over 34, which is the total masses, then the acceleration is equal to 0.33 approximately meters per square second. Okay, my system is composed of the ball and the box. Newton's second law tells us that the F external, but maybe we have more than one F, so it put the summation. That means the first force, the second force, the third force is equal to the acceleration and the total mass of my system. The total mass of my system is m1 plus m2. This is the acceleration. We find it, which is 0.33 meters per square second. The total forces, external forces, the external forces here is the mass multiply is the weight of the ball and the effective weight for the box, which is the weight for it multiplied by sine theta. But you remember this case, we have the weight and we have friction force, but the weight of the first box here is acting normally on the surface. There is no parallel component for the weight. The parallel component is 0. Okay, we don't have a parallel component of the weight for the first case in the previous question. But here we have parallel component of the weight. And we don't have any friction force here. So we don't care about the friction force. Just we have two external forces. The weight of the first body and the weight of the second body. This is the second. This is the weight, the first, multiplied by sine. The tension force are cancelling each other in our equation here. So they are, for our system, they are internal forces. We don't care of them. But for just one body, the tension and the weight are external. For this body, the tension and the weight are external. But for our old system, this is all of my system. This and this are the external forces. This is are internal. Newton's law does not care about them. This is the first. And Newton's third law make them cancel each other. Okay, also Newton's third law make this and this cancel each other. They are external, but they are cancel each other in perpendicular to our motion direction. Okay, I think the second required is to find the tension. I can use equation number 1 or equation number 2. Equation number 1 is m2 multiplied by g minus t for the ball, this one and this one for the ball, and this is for the box. For the ball, I can move t to here, it will be positive, and I can move this to here, it will be negative. This is t is equal. You can prove and convince yourself that's right. And these are the values, all are known, and this is the tension force. For using the second equation, it will give me the same result. Okay, the second equation, just I need to move this to the second part here, the second side. It will be positive. I need to put the values, then I will get the same answer. Try this by yourself. The number of times that you try to solve these examples, that make you more strong or more faster, and if you have any mistake, you can find it easily. Thank you. I will see you in the next examples.